Welcome back, Algebra 3. We're in Lesson 43. This is Section A. We're going to talk about periodic functions. First, let's refresh our memory on the functions we've learned so far. Now, we spent a lot of time on linear functions. You should know those backwards and forwards at this point. A linear function is a line. The key word here, we see it within line. And the formula for that is y equals mx plus b. The next one we talked about were quadratic functions, and those are functions or equations where the x has an exponent of 2, and that's going to make a parabola shape like this. So a quadratic function has the exponent of 2 and it creates a parabola shape. Then we talked about just recently exponential functions, and exponential functions are where your exponent is the x and it creates this weird little swoopy graph right here that kind of hugs the line on one side, or hugs a line on one side. So these are the three that we have talked about so far. So let's talk about, now we're going to learn periodic functions. So when I say periodic, that should bring to your mind images of time. Periodic, that's why we call magazines periodicals, because they come out at a regular time frame. So think to yourself polygraph. When somebody and you see the little needle and it goes up and down like that, that is a periodic function. Okay, seismographic information, what do they call those things? I don't know what they call them, but it measures seismic activity, like how big that earthquake was, or how big the tremor was, those types of things. That is a periodic function. All right, so let's look at the a periodic function. Let me put a picture of that up here. Now, there are some things that we need to learn about periodic functions. There's some terminology that we need to use, and we're going to mainly focus on these periodic functions that are static, that are a wave of some kind, like different elements produce a wave that measures at the same thing every single time, both up and down. So let's talk about the up and down. The up and down is called the range. That makes sense. We've used that word before. So range is going to be the limit, the maximum and minimum limit of the periodic function. So the highest point and the lowest point, that is the range of your periodic function. The amplitude of your function, so the amplitude of a function is going to be the same both above and below. So the amplitude is the distance from the midline. Or the axis. In this case, we're using the axis as our midline, but you could position it anywhere you wanted to on the map or on the graph. We're just going to use our axis here to be our midline, just because it's easier to see where the midline is when we use the axis. All right, so the range is the max and min, and the amplitude is the distance. So what that means is the amplitude, we're going to use a unit of 1 just because it makes it easier to see. Our amplitude here is 1. That means it's going to go 1 above and 1 below the axis. The range is +1 to -1. Okay, so it's wherever the highest and the lowest limit is, and they are typically the same, right? The same distance from the midline. That's why it's called the midline. So you find the middle section or the midpoint, and that is where your axis is. The range is going to be from the highest to the lowest, and the amplitude is that it's like you take the range and divide it by 2, and that's your amplitude. All right, so that would be range divided by 2. All right, so there's another part, and I can't really explain that until after we start putting in points. But before we start putting in points, I wanted to kind of illustrate, let me come down here and illustrate how this is going to work. If you notice here on our periodic function, x-axis has been changed to theta. And that just means that we're measuring things on the x-axis in degrees instead of units. So let's illustrate how that works. So imagine we have a circle or a Cartesian coordinate system, right? And we measure it typically when we are doing the sine and cosine and tangent. We're measuring our angles and our vectors on here. We are measuring them using the terminal measurement, where this is 0, this is 90, this is 180, and this is 270, right? And then when we come back around, this also becomes 360. So that is, if you think of it, this is up, back to the middle, down at the lowest point, and then back up to, it's a circle, right? It becomes a circle. This is just a snapshot of one motion, of one angle. It is one rotation of the degree of measure. The periodic function records, remember we did multiple rotations, like we would have a 720-degree rotation? That is what this is going to be. A periodic function is going to record more than one rotation, more than one single snapshot of the function. It's going to record it over time. That's why it's called periodic. But we're going to take this little circle here and we're going to stretch it out. So then when you have this 180, as time happens, we don't stay in one place, we move. So we're going to move this circle as we move. That's why I say you have to think about it in terms of like a polygraph or a seismic recording device, whatever that, I can't remember what that's called. But that is what we're going to be drawing here. And there are specific characteristics of the two different kinds of periodic functions. So you have a sine function. And that one, let me write the formula for that instead of just sine. So with a sine periodic function, you have y is equal to b sine of theta. All right, this b, you're going, why is that a b? Here's why it's a b. There's a much more complicated formula for periodic functions, and it looks like this. Y is equal to a plus b times sine times theta minus d. I'm sorry, I forgot the c. Sine times c times theta minus d. So that's a lot, right? We're just going to focus on this part. This is the part, this half of it. We're just going to do half of it. So don't worry about that just yet. We're going to add the little bits as we go along. We're going to take little bitty bites of it so we can understand each part. B is the amplitude. All right, this is the sine function formula. B is the amplitude. And of course, theta represents the axis here. All right, it's going to represent where it's located at. All right, so now let's just look at some points. Let's just go ahead and start with that. I'm going to start with blue just to give you some ideas here. Now there's a certain pattern that you're going to follow every time. And for y equals b sine of theta, this is what you're going to have. Let me make a 90. Actually, I'll start with 0, then 90 degrees, then 180 degrees, and then 270 degrees. We'll go a full 360. If my pen will, it's like stuck. Come on, pen. There we go. All right, and then 360. All right, so at 0 degrees, you are at 0. At the 90-degree function, you are at positive 1. At 0, remember the circle here? At 0, we're at 0. At 90, we're up. So that's why it's positive 1. At 180, we're back at the 0. So we're back at 0. At 270, we're down on this polar negative y side. So we're at negative 1. And then we're back up to 0 with our circle. So at 360, we're back at the circle, which is the starting point again for another rotation. So that's what we're going to do here. Our first point is 0. Then at 90, we're at positive 1. At 180, we're back at 0. At 270, we're at negative 1. Then at 360, we're back at 0. At 450, we're at positive 1. 540 is 0. 630, we're back at negative 1. So you can see, and we can even do that on the negative side. So on the negative side, this is negative 90. So this negative value is multiplied by your amplitude. So that gives you a negative 1. So this will be back at 0 because 0 is neither negative nor positive. It's always just 0, right? So then that gives you this pattern here. You can almost see the circles form. You get a half circle above and a half circle below every time it makes its full motion, right? This is a half circle. This is a half circle. So you can see how they would fit together on the Cartesian coordinate system that we're used to. So I hope that that makes sense. Now you this is the illustration I needed to talk about the other term that you have. You have a term called a period. Yes, we all know what that is. And it relates to that. That I'm hinting at relates to this as well. A period is a full circle on a periodic function. So a full circle. So from here, from your 0 point, my pen locked up on me again. Here it is. From your 0 point, which is here, to your next 360 degrees, which is at the 0 point again, this is a period. A period is, I'm going to put it here just so that I don't mess up my table here. A period is equal to 360 degrees. And it could be any 360 degrees. It doesn't have to start at 0. You go from 90 to 450. It's still 360 degrees. Come on, pen. There it goes. It's still 360 degrees. You just started at 90 and you went here. So a period is 1, 2, 3, 4, because you have 4 quadrants of 90 degrees. It's 4 sections or 4 quarters of the circle. So this is a period. But then this is also a period. So it's just a 360 degree section that gives you a snapshot. Think Cartesian coordinate system. It is that snapshot of your function. That is what a period is, and that's what you're going to use to identify the range and the amplitude and all of that, right? So that is why we needed to have the points drawn in order for me to illustrate what a period is on a periodic function. So now, what if we have a negative function here? What if this is a negative b? How do we handle that? B is going to be a whole number. Right now, this function right here, because it has a value of 1 for your amplitude, this b would go away, and this would actually be written as y is equal to the sine of theta. Why? Because 1, just like in every other equation we've ever done, whenever we use any other variable, whenever it's just 1 times something, we don't write the 1. So the b, when it's not present, b is 1, just like any other time, okay? What if b is negative? What if we have a negative number for our b? Right, well then you write it. Then you'd write negative b sine of theta, or you would say y is equal to the negative sine of theta, just like we would for any other variable. Okay, that would be your option here. I'm just going to go ahead and write this, put this back up here, just so you have your example of what you would write. Now, B, again, is your amplitude. So if this went all the way up to 6 or 3 or 2, then you would have the whole number that it goes up to. So that would be 2 sine. If this went up to a number 2, this would be y equals 2 sine of theta. If it is a negative number, I'll show you how that works. A negative periodic function, a negative periodic sine function, goes down first because the value here is multiplied by -1. So that would be, it would start at the 0, right? Let me get pink for this so you can see it better. And then it would go down to -1 first, and then back up to 0, and then it would go here to the +1 at 270, and then back to, back here, and then back here, and then here, and then here. And then it would be here, of course. So you would have this action going. So a negative sine periodic function is going to go down first when it leaves the origin, where it crosses the y-axis. So a sine periodic function, let me put these values in, it's 0, -1, back to 0, then +1, then back to 0, all right, for your period. All right, this is your period here. So I'm going to make a little note here. A sine function crosses the y-axis at the origin. And we know the origin is 0. Okay, so that is a sine function, and it crosses the y-axis at the origin. That's where everything starts on the y-axis for a sine function. So what is the difference between a sine function and a cosine function? Good question. I'm so glad you asked that. That is the other type of periodic function that we have. That is a cosine function. So I am going to, I have room. I'm going to draw, this is a sine function. I'm going to label it. I'm going to label it with black because sine function. And let me put this in here. Voila, the beauty of technology. Actually, do I have room over here? I do. I'm going to do this over here. Let me erase this for us so I can bring this closer. I lost it. It went away. When I let go of it, it drops it. So I'm just going to paste it again. It'll be fine. Actually, I think I'll just go below. That might help. All right. So a cosine function, here's the difference. Cosine function crosses the y-axis at the amplitude. So if it is a cosine function, it is going to either start here or here on the y-axis. That is where it's going to cross. Sine function crosses at the origin. Cosine function crosses at either the top amplitude or the bottom amplitude. Now, if it crosses at the top amplitude, guess what? It's a positive cosine function. If it crosses at the bottom, it is a negative cosine function. That should make perfect sense. So let's look at those points here. I might need to move this and make a little bit more room. Let's move this down a little bit. All right, so this would be y. Let me go back here. No, that's fine. We'll just do that. Y is equal to cosine of theta, right? This is going to be your positive, so this y is equal to b cosine of theta, where b is the amplitude. So this is going to be positive, is a positive b. So we're going to start at the positive 1, then go to 0, then go to negative 1, then go to 0, then go back to positive 1. So let's plot that down here. So we're going to start at positive 1, then go to 0, then go to negative 1, then go to 0, then go back to positive 1, then back to 0, and so forth and so on. So this is what this looks like. You can see it crosses at the amplitude. So that is the difference between the sine crosses the y-axis at the origin and the cosine crosses the y-axis at the amplitude. Now, if it is a negative, so this will be y is equal to negative cosine of theta, which is going to be y is equal to negative b cosine of theta. This would be negative 1, 0, positive 1, 0, negative 1, right? Just the opposite applied. So then this would start here, come here, then cross the negative on the y-axis, back up to here, cross here, here. So then it would look like this. It would go down first at the y-axis. My drawing skills leave a little bit desired on that one. Let me see if I can do that a little bit better. Totally missed it. All right, I'm going to get it right this time. All right, much better. I'm happier with that one. It's not perfect, but it'll do. So you see the difference. The cosine, negative cosine function, first of all, cosine crosses at the y-axis at the amplitude. The negative cosine crosses at the negative amplitude. The positive cosine crosses at the positive amplitude. So those are the two differences between the sine function and the cosine periodic function. All right, and these are your different formulas for that. So when it crosses at the y-axis, you're going to have positive or negative b is going to be which one it goes to. Does it go to the positive amplitude? If it goes to the positive amplitude, then it is a positive b. If it goes to the negative amplitude, then it goes to the negative b. It is a negative sine periodic function. If it is a positive cosine periodic function, then it crosses at the positive amplitude at the y-axis. If it is a negative cosine periodic function, then it crosses the y-axis at the negative amplitude. Those are the two main differences. Okay, and you can call this x if you want to. There's just a little side note. Most people use theta. In the book, it goes back and forth between x and theta. So it doesn't really matter. You just know that this is your degree of measure, right, that you're at. All right, so let's try a practice problem. And it might take me a second to draw this. So I am going to pause and make sure you have all of these notes right here. This is going to be very important so that you know how to see the pattern. And this 1 in here is just an example, right? Whatever the amplitude is, that's what you would substitute in for the positive and negative ones. So if the amplitude is 6, this will be a positive 6, this will be a negative 6. This will be a positive 6, negative 6, negative 6, positive 6, so forth and so on, right? So just B is the amplitude, and these are the B's. And whether it's positive or negative is what it's giving you. These are your function formats, which you're gonna need to make sense of all of that. And then just understand the terminology so that you can read and talk about this correctly. All right, you don't want to do like me and use the wrong terminology back and forth and get everybody mixed up. So I'm going to clear the page. We're going to do some practice problems. All right, so here we have 2 practice problems for this lesson. That's all we have. So we're going to write the equation for each of these sinusoids, which is a fancy way of saying periodic function. So the sinusoid here, this begins or it crosses the y-axis at the origin. So that tells me right away it is a sine periodic function. So I can begin by saying y is equal to, of course, but now I need to know what my amplitude is. And my amplitude here, it goes up to a positive 6 first. So this is a positive sine sinusoid. So I can just write 6 sine theta. That's it. All of that explanation, that's all we have to write. Okay, so it's not super hard right at the beginning. It will get a little bit more difficult as we add parts to our formula and we learn the different parts of that. And I think that's why he does that in our curriculum, to break it down so that you understand each little bit as we go. He does a decent job of that. All right, so 43.2, notice on our theta axis that we have the pi symbol. Remember what the pi symbol means. It's just 180 degrees. So 180 divided by 2 is just 90 degrees. 180 is 180. 3 pi divided by 2 would be 270. And then 2 pi would be 360. So this is just an illustration of how you might see one of these written, for the sake of, I don't know, maybe they can't do multiply, the multiples of 90. I don't know. I don't know why they would do it, but this is just to remind you of what that means. And it's also kind of there to throw you off. So you're like, what? So it's just testing your memory and cementing the concept a little bit further. So don't get thrown off by that. This is 90, 180, 270, 360, 450, 540, 630, just like what's up here. All right. So this starts at the amplitude. So that tells me right away that this is a cosine function. So, or a cosine sinusoid. So it's also starting at the negative amplitude. So this is going to obviously be y is negative 3 cosine of theta. That's it. That's the answer. Now, I will say this. If this is written as x, and it could be either one, then you would write this as x. So look at what your graph is labeled with, and that is the unit of reference that you put on your formula, and that's what makes it correct or incorrect when you type it in the system, because that's going to be there also. All right, that's it. That is all we had for lesson 43. I know there was a whole lot of lecture and not a lot of practice problems, but you have a good understanding now of what we're looking at, right? You know that from here to 360, 0 to 360 is a period. You know the amplitude is the distance from the axis up or down, and the range is the top to the max to the min. The period is, again, the 360 degrees anywhere on our, a stretch of 360 degrees anywhere on our function. And that it is in reference to the degrees of the circle on our Cartesian coordinate system. And that's how we can go further, is because this is the over-rotation pattern of that. You also know that a sinusoid, periodic function, whatever you want to call it, crosses at the origin on the y-axis, and that a cosine sinusoid, or periodic function, crosses at the amplitude, be it positive or negative, and that affects the amplitude affects the b value at the beginning before the sine or the cosine. All right, so negative, if it begins here, it's negative. If it goes down first, it's negative. If it goes up first, it's positive. It's pretty much all you need to know in order to write these correctly for now. We'll get into more detail later. All right. So that's all I have for lesson 43. Have fun with that, and I'll see you in lesson 44.